Dear students, welcome back. Today is the 9th lecture and we are doing practice at 1.4. In this exercise, sums 1 and 4 are already done. All other sums I had given you for the homework. Sum number 2 and sum number 3 are fill in the blank like question. So we will solve. In the second sum, it is said that triangle ABC is similar to triangle PQR and ratio of side AB to side PQ, corresponding sides of the two triangles is 2:3. Then fill in the blanks. Area triangle ABC upon area triangle PQR is equal to AB square upon PQ square. Why? Because in the beginning of this exercise, we had studied the theorem. What is the name of the theorem? Theorem on areas of similar triangles. Understand? What is this theorem? The theorem says that if two triangles are similar, then the ratio of their areas is equal to the ratio of squares of their corresponding sides, and ratio of corresponding sides is given to us. So AB square upon PQ square. Reason they have not asked, but we should know. 2 square upon 3 square. So we write here 3 square. Boxes are given to be filled by us. 2 square is 4, 3 square is 9. So this is our answer. Area of triangle ABC ratio area of triangle PQR is equal to 4:9. Sum number 3 now. Third sum says if triangle ABC is similar to triangle PQR and area triangle ABC is 80, area of triangle PQR is 125, then fill in the blanks. Area triangle ABC upon area triangle PQR is equal to 80 by 125. Values are given. Therefore, AB upon PQ is equal to blank. So, if you recall the previous sum, in the second sum, what we did? Area triangle ABC upon area triangle PQR is equal to, since the triangles are similar, the ratio of areas of the two similar triangles is equal to ratio of squares of the corresponding sides. So corresponding sides will take AB and PQ, AB square upon PQ square. You know the reason. Theorem on areas of similar triangles. Theorem on areas of similar triangles. Please write the full form, not the short forms. Now we are given the areas of the two triangles. 80 by 125 is equal to AB squared upon PQ squared, because the ratio we have to find. Now can we cancel this? Yeah, in the table of 5, 16 5s are 80 and 25 5s are 125. Now in order to remove these squares, we take the square roots on both the sides. So square root of 16 upon 25 is equal to AB upon PQ. So therefore, what is our answer? Final answer. So AB upon PQ is equal to square root of 16 is 4 and square root of 25 is 5. This is our answer. So what we write here? Here we write 4 and here we write 5. So ratio of the corresponding sides of the two similar triangles would be 4:5. Okay, this is the sum number 3. Now we will go to solve the sum number 5. It says that areas of two similar triangles are 225 square centimeter and 81 square centimeter. If a side of smaller triangle is 12 centimeter, then find the corresponding side of the bigger triangle. Now first find out which is the smaller triangle. Triangle having area 81 square centimeter is the smaller triangle. Now how will we write in the solution? Definitely we have to use the theorem on areas of similar triangle, which we did before this practice at 1.4. But we will assume here, let the areas of two similar triangles be A1 and A2, and their corresponding sides be S1 and S2 respectively. Understand? So we have to first assume areas to be A1 and A2 for the two similar triangles and their corresponding sides to be S1 and S2. Now we know the theorem, application of the theorem on similarity areas of similar triangles. A1 upon A2, what is the theorem? The ratio of areas of two similar triangles is equal to ratio of squares of their corresponding sides. So this is according to theorem on areas of similar triangles. Understand? Now put the values. A1 is 225. So we write 225. A2 is 81. We write 81. Side of the smaller triangle, be very careful now. We know that this is the smaller triangle, A2 is the smaller triangle. So we are given S2, which is equal to 12. So we write here 12 square, and we have to find the side of the bigger triangle. So S1 square will remain as it is. All these values are given. So what we do now here, cross multiplying. 225 multiplied by 12 square is 144 is equal to 81 multiplied by S1 square. So what we do here, 225 into 144 upon 81 is equal to S1 square. Taking square roots on both the sides, rightful form on both the sides, we get, what do we get? Square root of 225 into 144 upon 81 is equal to S1. Square is removed. Now we know the square roots. 225 is a perfect, all are perfect square. So it is 15 into 12 upon 9. That is S1. We can cancel this. 3 3s are 9, 3 5s are 15, 3 1s are 3, 3 4s are 12. So we get S1 to be equal to 5 4s are 20 centimeter. So the corresponding sides, finally we have to write in words that the corresponding sides of the bigger triangle will be 20 centimeter. Write the answer. Because of the lack of space I am not writing, but in the end of this answer we have to write that the corresponding side of the bigger triangle is of length 20 centimeter. Now the next sum. This is the sixth sum. Triangle ABC and triangle DEF are equilateral triangles. Area triangle ABC, ratio area triangle DEF is equal to 1:2. Side AB is 4, find side DE. Okay, so in the solution what we will write? Remember, this exercise is based on the theorem on areas of similar triangles only. Now, triangle ABC and triangle DEF are equilateral triangles. Reason given. Now we know in equilateral triangle all angles are 60 degree. So angle A equal to angle B equal to angle C equal to 60 degree. Each angle is 60 degree, and angle D equal to angle E equal to angle F equal to 60 degree. Reason, each angle in an equilateral triangle is of measure 60 degree. Understand? So these are 60 degree angles. Therefore, in triangle ABC and triangle DEF, we see that three angles of one triangle. Angle A congruent to angle D, angle B congruent to angle E, angle C congruent to angle F. This we get if this is result number 1. So we can say from 1. So this gives us the idea that the triangles are similar. So triangle ABC is similar to triangle DEF. By which test? A test. We could have proved the two triangles similar by SSS test also, because equilateral triangles are always similar triangles. Any two equilateral triangles are always similar triangles. But we have to prove. So we proved it. Now once we get the areas, once we get that the triangles are similar, we have to use the theorem. Now what we write? Area triangle ABC upon area triangle DEF is equal to AB square upon DE square. What is the reason? Theorem on areas of similar triangles. Please write the full form. You don't have to write short forms. Now we are given the values. Ratio of these two areas is 1:2. So 1/2 is equal to, side AB is given 4. So it is 4 square upon D square. Now what we do is cross multiplying. D square is equal to 4 square is 16 into 2. Therefore DE is square root of 32, or 16 into 2 we can even write 16 into 2, because I removed the square, because I took the square root. So reason we can write taking square root on both the sides. Full form please you have to write. Therefore DE is equal to square root of 16 is 4. 4 root 2. 2 is a prime number. It will remain inside the square root sign. So length of side DE is equal to 4 root 2 units. This is how we can get DE. So here also you saw the application of theorem on areas of similar triangles. Sum number 5, sum number 6. And now the last sum we are doing of this exercise, it is sum number 7. In the seventh sum, it is said that in triangle DEF, segment PQ is parallel to side DE. These two are parallel. Area of triangle PQF, small triangle you are seeing, PQF is 20 square units. In the textbook it is given 20 units, but actually it should be 20 square units. And side PF is twice of side DP. PF is this, is double of DP. Okay, this is given. We have to find area of quadrilateral DPQE. DPQE, this small part, this quadrilateral, area of this quadrilateral we have to find by filling the blanks. So student, the solution is given. All the blanks I have kept here. It is said area triangle PQF, this triangle, area of this triangle is 20 square units, and PF, it is said PF is 2 times DP. This segment PF is double of this segment DP. So what we have done here, what they have given here, let us assume DP equal to X. This part is X. Now PF is double of X, so this will become 2X. So PF is 2X. Now DF, entire side DF will be DP plus PF. So here we will write PF, which is equal to DP is X. So this is X and PF is 2X. That will give you 3X. Okay. These three boxes are, that's why filled like this. Here PF, here X, here 2X. Now, coming to prove the two triangles similar. Triangle FDE. Triangle FDE, the entire big triangle, and triangle FPQ. In these triangles we see angle FDE. Angle FDE. This angle is congruent to this angle FPQ. Reason corresponding angle. So here we have to write FPQ. These two are corresponding angle because these two lines are parallel and this is the transversal. Similarly, if you consider same parallel line and this line is a transversal, so angle FED, this angle will be congruent to this angle, that is angle FQP. So here I will write angle FQP, corresponding angles. So these triangles where two angles are congruent to each other become similar. Triangle FDE is similar to triangle FPQ by double A test. So we have to prove the triangle similar. They have given the triangles are similar, big triangle and the small triangle. Now again coming to use the area theorem on areas of similar triangle. We know that area triangle FDE upon area triangle FPQ is equal to corresponding side. Which corresponding side we will take? We take FD square upon FP square. Now FD we already got. FD is 3x. So here we write 3x square, and FP we got 2x. PF is 2x. So we write 2x. Now 3x square is 9x square. The 2x the whole square is 4x square. X square cancelled. So we are left with 9 upon 4. So area triangle FDE upon area triangle FPQ is equal to 9 upon 4. Bringing area triangle FPQ to this side, we get area triangle FD is equal to 9 upon 4 area triangle FPQ. So 9 upon 4 into area triangle FPQ is given to us. It is 20 square units. So I have to write here 20 because it is given. Cancelling 4 and 20 by 5. 4 5s are 20. We have 9 into 5, 20, 45. 9 5s are 45 square units. 45 square units. Okay, so we get that area of the triangle FDE is 45 square units. Now when triangle FDE, area triangle FDE is 45 and area triangle FPQ is 20. So to get the area of this quadrilateral DPQE, what we do? From big triangle FDE we subtract triangle FPQ. So area triangle FDE minus area triangle FPQ, which is equal to 45 minus 20, and that will give us 25 square units. So area of quadrilateral DPQE is equal to 25 square units. Why? Because the bigger triangle is area 45 square units and smaller triangle is already given having area 20 square units. So from 45 if you remove 20 we get 25 square units. That is how we can get the area of quadrilateral DPQE. This is again a fill in the blank type of question. This type of question can also be asked in the board examination, wherein we are using theorem on areas of similar triangles. Okay. Now we'll solve the sums from problem set 1. We will see how many sums we can solve in this lecture. Otherwise, I will advise you to solve actually all the sums of the problem set 1 by yourself. It is a good practice. Why? Because now you are knowing all the theorems and properties of this chapter, and problem set 1 is the use or the application of all those theorems and the properties. So it is always advisable to solve all the sums of the problem set by yourself. As many sums you solve using theorem and property by yourself means if you solve the sums by yourself, it will be a good practice. Students, in the problem set 1, I expect sums 1 to 5 to be solved by you. Homework sums. First question being the MCQ. There are certain MCQ multiple choice questions are given. Another second, third, fourth and fifth are very simple questions. So please try them solving at home. In the sixth sum, it is said that triangle MNT is similar to triangle QRS, and sec TX is the height or altitude on side MN, which is 5, and SY is altitude on side QR, which is 9. We have to find that area triangle MNT upon area triangle QRS. How much is this ratio? This ratio we have to find. So how to do in the solution? What we'll write? We have triangle MNT similar to triangle QRS. Reason it is given. So we can say that angle M is congruent to angle Q, corresponding angles of similar triangles. Result number 1. Why we took M and Q only? This will be useful to us. Okay, now we take smaller triangle. In triangle TXM, and another triangle looking similar to that is SYQ. Okay, triangle SYQ. We notice that one angle is 90 degree. So angle TXM is congruent to angle SYQ. Reason, each is 90 degree. Each is a right angle. Okay, by given perpendiculars, these are XT and SY are perpendicular. So these are right angles. Also we have here written angle M congruent to angle Q. From 1 we can write, see, we used this first. Okay, we already proved here. Therefore, we see that triangle TXN is similar to triangle SYQ. By which test? Angle test of similarity. Now when the triangles are similar, their corresponding sides are in the same proportion. Now which corresponding sides? TX upon SY. TX upon SY is equal to TM upon SQ. TM upon SQ is also equal to XM upon YQ, but we will not write it. But we know that TX upon SY, TX and SY both are given. So 5 upon 9. So what we have to write? Corresponding sides of similar triangles. And also another reason we will write is given. Because TX and SY are given 5 and 9 respectively. and this ratio is equal to Tm by SQ because the triangles are similar, so corresponding side should be in proportion. Okay, once we get that ratio Tm is to SQ is also 5 upon 9, then we can again using the same given thing, the triangle MNT similar triangle QRS, and using the theorem on areas of similar triangle easily find the ratio of these two areas of these two triangles. So what we have to write now, area triangle MNT upon area triangle QRS is equal to corresponding sides, which we will take corresponding side Tm and SQ, that is equal to Tm square upon SQ square. Reason, theorem on areas of similar triangles. Please write the full form. Because of the lack of space I am writing this way. Now we have to find this ratio, and Tm is to SQ already we found. Let us give this as result number 2, which we'll be using here. So area triangle MNT upon area triangle QRS is equal to, from 2, so the value is given Tm by SQ 5 by 9, so it is 5 squared upon 9 squared, which is equal to 25 upon 81. So we got the ratio of areas of the required triangle. So area triangle MNT ratio area triangle QRS is equal to 25 upon 81. This is the required answer. So very simple sum. One or the other way we will use the different properties or theorems which you have studied to solve the sums of problem set. Students, I really and very seriously expect from you that you should solve all the sums of the problem set. Why? Because if I will give you all the answers, you will just watch and listen. That's all. You will not be doing self practice. For self practicing, for proper application of theorems and properties, okay, you need to solve the sums by yourself. So I expect you to solve all remaining sums of the problem set. However, now in the next recorded lecture, we will solve the remaining sums of the problem set 1, so that if you have any doubt in case, then the doubt will be solved. For today, this much is enough. Now we will meet in the next lecture. This is the conclusion of the present lecture. Have a nice time. Stay at your home. Do not go out. Take care of your health. Goodbye.